Okay, in today's lecture, we'll start with what is a scalar field and what is a vector field. So, in my previous lecture, we had talked about dot product, cross product, their properties, and how we can uh, see some numericals based on that. And today, the first topic which I will be covering is scalar field. Okay, what is a scalar field, and then what is a vector field, and what are the examples of it. So the first thing I have written here, you see, this is scalar field. So scalar field is defined as the region in space in which a scalar quantity has a unique value at every point in space. You say, for example, you have a scalar quantity and you take any point in space and you see it has a unique value there. हर जगह उसकी एक specific value होगी and that field is known as scalar field. When the quantity is scalar quantity we are talking about in space at a point where it has a unique value, then that is known as a scalar field. So at every point in the space is called a scalar field. For example, पहला example दिया हुआ temperature field or distribution of temperature. Temperature field, you see temperature is what? Temperature is a scalar quantity because once we say what is the temperature in this region, how much is this? Say for example, right now it is 26 degrees Celsius or 18 degrees Celsius or 19 degrees Celsius, whatever. In space, you always check in your mobiles also. Say sometimes you are sitting in Kangra or anywhere else, then you see what is the temperature right now. So the region in space where the scalar quantity has a unique value at every point in space. Then if you go to some other place, there the temperature might be different, but it will be static there in some particular region in space. There it can be 26 degree or 28 degree in a particular area. So this is called temperature distribution field or temperature field. So temperature field is an example of scalar field. Then second example I have written here is electric potential density, etc. Electric potential density. You can see the potential, electric potential at some place, it has a one particular value. So electric potential is a scalar quantity. Once the region in space where it has a unique value at every point in the space around that space, then we say that this is a scalar field. So this is the second example, and now you see how we can represent it. So this is phi. Phi is a letter. You see, phi is a letter with which this temperature field is, with this scalar field is represented. यहाँ जैसे electricity and magnetism में, say for example, if phi is written in this manner, that phi is equal to phi of r. R means space. R means space. So R means space means x, y, and z. Or we can write, it can be represented as phi of x, y, z, where phi is a scalar quantity. It is a scalar quantity. So this scalar field is represented by letter phi or phi equal to phi of x, y, z, where phi is a scalar quantity. So this is just a definition of scalar field and how we define it. Then comes second is say vector field. Second comes is vector field. The definition remains the same, only where the term scalar quantity is there, we will be writing a vector quantity, and this is called a vector field. So again the definition becomes the region of space in which a vector quantity has a unique value at every point in space is called a vector field. जैसे scalar field बोला वहां पे quantity क्या आ जाएगी, vector आ जाएगी. So जैसे temperature is a scalar quantity, if we are taking a vector quantity and it has a unique value in space around a point, around any point in space, it has a unique value, then that field which it will be representing will be known as a vector field. And the examples I can give you is, say for example, electric field. Electric field. Second example you can give as magnetic field. Magnetic field. Third also the field is say gravitational field. Gravitational field. जैसे electric field is say for example it is represented by letter E, magnetic field B भी कह देते हो, gravitational field, force field, gravitational force field. Let us say it is denoted by this. For example, sorry. So ये सारे के सारे आपके पास क्या आएंगे? वेक्टर फील्ड्स आ जाएंगे, और स्केलर फील्ड एंड वेक्टर फील्ड. एंड यू सी हाउ वी कैन रिप्रेजेंट इट. वेक्टर फील्ड जैसे उसको हमने स्केलर फील्ड को रिप्रेजेंट किया बाय लेटर फाई, और फाई इक्वल टू फाई आर विच इज इक्वल टू फाई ऑफ एक्स वाई जेड. Similarly, we can represent the vector field by a letter A. Say for example, ये A is equal to A of R. यहाँ पे वेक्टर डाल दिया. फाई के ऊपर वेक्टर नहीं था, दैट वाज द स्केलर क्वांटिटी. A is a vector quantity, और we can represent this as A of x y z. If it is written in this manner, A can be anything. It can be electric field, it can be magnetic field, it can be gravitational field, or whatever vector quantity we are taking here. So this is journal representation. So vector field is represented by this thing where A is a vector quantity, where A is a vector quantity. So these are the definitions of electric field and vector field and their examples. Now comes the second thing, second topic, and which is del operator. The del operator. Del operator, or sometimes it is also called vector differential operator, or vector differential operator. एक ही बात है. Either you call it a del operator or vector differential operator. So first thing is its symbol. See, whenever you see this kind of symbol, अगर आपको ऐसा symbol कहीं भी दिखाई देता है, then this is called del operator. This is very, very important, because as we will be proceeding in our next chapters or next topics, every time you will encounter this kind of symbol. So you must remember what is a del and how you can recognize it. You just see the symbol, and this is called del operator. This is called del operator. And it is defined as, you see what is the value of this del operator. So del operator is defined as I am writing this del, and it is always written in this manner: I cap del over del x, j cap, this is partial derivative with respect to y, or you can say del over del y, plus k del over del z. This is the definition of del operator. And remember this is very, very important. This is very, very important. You have to remember it, because we will be using this operator time and again. So del operator is this. Probably I will write here, that is del is equal to I cap del over del x plus j cap del over del y plus k cap del over del z. And you have to remember it, because this is very, very important, and this is called del operator. Then is very important thing about this del operator. Del operator देखिए, जब भी ये किसी स्केलर क्वांटिटी के ऊपर ऑपरेट करता है, then the resulting quantity we get is a vector quantity. We get a vector field, or scalar field ऐसे भी कह सकते हैं. Whenever this del is operated upon a scalar field, then it gives rise to a vector field. This is very important statement. That is, क्या statement बताई मैंने आपको? This is the statement: when the scalar field is operated, when a scalar field is being operated upon a del operator, it gives a vector field. अगर किसी भी स्केलर फील्ड के ऊपर डेल को आप लगा दो कि del is being operated upon a scalar field, then the resulting quantity which you will be getting is a vector field. This is very very important. This is a very very important statement. ये याद रखनी है आपने ये भी, because we will be using this statement again when you will see we will come across the next topics. Then next is ये del आ गया आपके पास. Then the next operator we will be talking about is Laplacian operator. Laplacian operator. So what do you mean by Laplacian operator? The Laplacian operator आपके पास क्या है? If you see this kind of thing, you see if we take the dot product of del operator with itself, del dot del, then what will be the answer? What will be the answer? Del dot del will give you what? As it is as a dot a. A dot a क्या होता है? या a dot b का क्या होता है? Magnitude of a, magnitude of b into cos of the angle, ab cos theta. So here it is del dot del. They are the same vectors. So what will be the answer? Answer will be del square. Why? Because you see del dot del, a dot b, magnitude of a into magnitude of b into cos of the angle between them. They are alike, they are parallel vector, equal vectors. तो एंगल क्या होता है दोनों के बीच में? ये एक वेक्टर हम इसको कहते हैं a, ये सेम वेक्टर ये है. If I say this is a del vector, this is a del vector, what is the angle between them? 0 degree. So इनका डॉट प्रोडक्ट लोगे a b cos 0. Cos 0 is 1. So what is del into del? Is del square. So that is why we have written here. So this is del square, and this del square is called Laplacian operator. So whenever you see del square, then this is called Laplacian operator. This is called Laplacian operator. And mathematically, what will be its value? जैसे आपके पास del की वैल्यू तो आपको पता है. Del you know, we know that del is given by I del over del x plus j del over del y plus k del over del z. This thing you know. Del आपको पता है. Now we want what is del square. So which implies that del square Laplacian operator is always written as del dot del. ये वैल्यू यहाँ पे सब्स्टिट्यूट कर दो एंड टेक द डॉट प्रोडक्ट ऑफ दिस. सो व्हाट वी कैन राइट, डेल की वैल्यू यहाँ पे लिखिए. वी नो दिस इज आई कैप डेल ओवर डेल एक्स प्लस जे कैप डेल ओवर डेल वाई प्लस के कैप डेल ओवर डेल जेड एंड टेक द डॉट प्रोडक्ट हियर. दिस इज डॉट एंड अगेन द सेम थिंग एंड अगेन द सेम थिंग, दैट इज आई डेल ओवर डेल एक्स जे डेल ओवर डेल वाई प्लस के डेल ओवर del z plus k into del over del z. Probably you can see now. So we have simply taken the dot product with this. अब आप इसकी right hand side, we can always open this right hand side and this is equal to right hand side आप खोल लीजिए. तो पहले ये इसको क्या करो, इन तीनों टर्म के साथ डॉट प्रोडक्ट लीजिए. You see I cap del over del x dot I cap del over del x. So this is I dot I and I dot I क्या होती है वैल्यू इसकी? ये आइडेंटिटी मस्ट नो k dot k. I dot I plus equal to j dot j equal to k dot k is always equal to 1 and I dot j equal to j dot I equal to k dot I or equal to I dot j dot k dot I. This is equal to 0. ये जो डिफरेंट आ जाते हैं because here you see the angle between them is what? I j k. I और j के बीच में 90 डिग्री है तो a b cos 90 0 0 0 and here angle is 0. So I dot I is 1, j dot j. You have done this thing in your plus 1 plus 2 also. These are the properties. That is why I told you to just revise the properties of dot and cross products. So here we will be applying, this is I dot I. The first term will survive. So I dot I is 1 and del over del x into del over del x. This will give you del 2 by del x square. Now first term is multiplied by second. This is I dot j. ये 0 हो जाएगी. I dot k. This will again be 0. then j dot I, this term again is 0, j dot j will survive. So j dot j is 1 and this is j dot j. This is 1 and del y, del over del y into del over del y plus del 2 over del y square, and similarly the third one, that is del 2 over del z square. तो ये आंसर आ गया आपके पास, and this is Laplacian operator. This is important. You have to remember this, what is the value, how mathematically we can represent the del square or Laplacian operator. ये आपके पास ये value आ गई यहाँ पे. So this is called del operator, sorry, this is Laplacian operator. This is Laplacian operator. तो यहाँ पे मैंने ये लिख देता हूँ value. This is del I del over del x, j del over del y plus k del over del z. Then what is del square? Del 2 over del x square, del 2 over del y square plus del 2 over del z square. So we have seen now these results, what is a scalar field, what is a vector field, how they can be represented. Second, then what is del operator and what is Laplacian operator. Then after that is the next topic is gradient of a scalar field. ये सब आपके बेसिक्स हैं एंड दे आर वेरी वेरी इंपॉर्टेंट. यहीं से आपका ये इलेक्ट्रिसिटी मैग्नेटिज्म का बेस बनता है कि व्हाट डू यू मीन बाय ग्रेडियंट ऑफ अ स्केलर फील्ड, कि ग्रेडियंट ऑफ अ स्केलर फील्ड क्या चीज है. तो एज द नेम सजेस्ट ग्रेडियंट लेना है आपने क्या ऑफ अ स्केलर फील्ड. सो इफ आई से दैट से phi is a scalar field, say for example phi is a scalar field, ये लिखा है स्केलर फील्ड, phi आ गया. whenever the word gradient is there, gradient का मतलब ये होता है कि when a scalar field is operated upon by a del operator, जो भी स्केलर फील्ड है उससे पहले आप क्या लगा दो, del लिख दो, तो that is known as gradient of a scalar field. That is called a gradient and you will not put any dot or cross or any sign in between. Simply अगर gradient of a scalar field मतलब ये है कि ये scalar field है, it is being operated upon by del operator. So if I am writing del phi, there is no dot, there is no cross. This is important. You have to write only del phi. So this is known as, इसको हम ऐसे भी कहते हैं grade phi. Grade means gradient. This is a language which we'll be using here. If somebody says what is gradient of phi or gradient of a scalar field, you'll be writing del phi, where phi is a scalar field. तो ये आ गया gradient of a scalar field whenever a scalar field is being operated upon by del operator, then it is known as gradient of a scalar field. Then it is known as gradient of a scalar field. तो ये चीज है आपके पास और इसको आप ऐसे लिखते हो ग्रेड फाई एंड मैथमेटिकली क्या आ गया, दैट इज डेल फाई और ग्रेड फाई इज इक्वल टू, अब देख लीजिए डेल इज दिस, राइट डाउन डेल, डेल इज आई del over del x, j del over del y plus k del over del z, और साथ में क्या फाई, तो फाई ऐसा आप बाहर लेते हैं. This is mathematically how we write grade phi. And now you can open up the bracket. So this is I del phi by del x plus j del phi over del y plus k del phi over del z. This is known as del phi. This is known as gradient of a scalar function or gradient of a scalar field. And remember, the result which we are getting, gradient of a scalar field, I told you this is very important information I am giving you, or I have told you that gradient of a scalar field answer क्या होता है, it is a vector quantity or it is a vector field. So gradient of a scalar field is always a vector quantity. And यहाँ पे लिख लीजिए आप, ये आप you can remember कि gradient of a scalar field is a वेक्टर फील्ड। ये जो रिजल्टिंग आंसर आपके पास ये आ रहा है, ग्रेडियंट ये है, अगर आप इसको क्वांटिटी को चेक करोगे, दिस विल गिव यू अ वेक्टर क्वांटिटी और वेक्टर फील्ड। तो ग्रेडियंट ऑफ अ स्केलर इज अ वेक्टर, ये ऑब्जेक्टिव टाइप में भी कई बार आपको पूछ लेते हैं कि इज इट अ वेक्टर, इज अ स्केलर और इट इज जीरो और वट एवर, देन द राइट आंसर विल बी ग्रेडियंट ऑफ अ स्केलर इज अ वेक्टर फील्ड और वेक्टर quantity. Then next is कई बार टर्म आ जाती है, दिस इज समटाइम्स यू विल एनकाउंटर दिस टर्म लैमेलर फील्ड। इफ इट इज रिटन समवेयर लैमेलर फील्ड, सो कोई भी फील्ड जो है आपके पास, एनी फील्ड or a field expressed as a gradient of a scalar function is known as a lamellar field, जो अभी मैंने आपको बताया। A field which can be expressed as gradient of a scalar field is known as lamellar field. Simple definition है, किसी भी field को अगर आप gradient of a scalar field से represent कर सकते हो, then that field is known as lamellar field. So that is the definition of a lamellar field. A field which can be expressed as the gradient of a scalar field or scalar field is known as lamellar field. For example, देखो lamellar field का a field expressed as gradient of a scalar field is called a lamellar field. उसको हम lamellar field simply कह देते हैं. For example, the vector quantities you see which can be expressed, हमें क्या चाहिए अब, क्योंकि gradient of a scalar is a vector quantity. So वो वाली vector quantities which can be expressed as the gradient of some scalar function or gradient of some scalar. So how we can write example, say for example, say electric field. देखिए इलेक्ट्रिक फील्ड हम कैसे लिखते हैं, E, and you see E can always be expressed as negative gradient of some scalar function. तो E जब आप देखोगे आगे हमारे इलेक्ट्रिसिटी एंड मैग्नेटिज्म चलेगी, many times we'll be writing that E can be written as minus del of V. E can be, अब ये देखिए del V, इसको नेगेटिव को छोड़िए, it has physical significance, I'll tell you whenever we will be writing this कि इसका क्या मतलब है। तो नेगेटिव को आप छोड़ो, साइन को छोड़िए, अभी E is equal to del V with negative sign. So electric field can be expressed as negative gradient of electric potential. V आपके पास क्या है, V is electric potential, और electric potential क्या चीज होती है, it is a scalar quantity. So electric field, and इसको आप gradient of electric potential लिया तो it is giving you what, electric field, and electric field is a vector quantity. So therefore remember that electric field can always be expressed as negative gradient of electric potential, where electric potential is a scalar function or scalar quantity. तो ये आपको ये इसका एग्जांपल आ गया कि ये फील्ड है, ये फील्ड कौन सा है, ये फील्ड E expressed as gradient of a scalar field with negative sign, E equal to minus del V. तो ये आपके पास एक एग्जांपल आ गया. Then again second is example I can give you is a gravitational force field. सेकंड का एग्जांपल आप ये ले सकते हो, gravitational force field, और here you see if I say F is gravitational force, then F can always be negative gradient of some scalar function. Scalar function यहाँ पे आता है U, which is called U is what? F can be expressed as minus del of U. F is gravitational force, gravitational field, ये force field, and this is equal to gravitational force field. It can be expressed as negative gradient of some scalar function. And what is scalar function here? We have written this as U. What is U? U is gravitational potential energy. U is gravitational potential energy. And potential energy आपके पास क्या है? This is a scalar function. This is a scalar quantity or scalar function. So gravitational force field or gravitational field is always equal to negative gradient of some scalar function. This is important statement that certain fields can be expressed as negative gradient of some scalar functions. So this is about this, and so therefore general statement again यहाँ से निकल आएगी कि vector field can always be expressed as negative gradient of some scalar field. अब इस पे देखिए कुछ numericals भी आ जाते हैं. Sometimes I'll give one short numerical based on this and you can try more. And one important say numerical on the based on this del is if phi given numerical है you are given that phi, that is a scalar field is given to you xyz, phi of xyz is equal to 3x square y minus y cube z square ये आपको दिया हुआ है. अब पूछा गया कि आपने कैलकुलेट करना है. कैलकुलेट द ग्रेडियंट ऑफ फाई, calculate gradient of phi at point 1, at 1, -2 and -1. इस पॉइंट के ऊपर ग्रेड फाई निकालिए. Now you know the definition of gradient of phi and this is very simple. You just put the values and get the answer. तो हमने क्या किया, जैसे हमें पता है कि ग्रेड फाई हम कैसे लिखेंगे. ये पूछा हुआ है कि व्हाट इज ग्रेड फाई और डेल फाई, ये निकालना है हमने. ग्रेड फाई और डेल फाई इज इक्वल टू, यू राइट द वैल्यू ऑफ डेल. डेल ऑपरेटर होता है आई डेल ओवर डेल एक्स जे डेल ओवर डेल वाई प्लस के डेल ओवर डेल जेड. साथ में फाई की वैल्यू लिख दीजिए. फाई 3x स्क्वायर वाई माइनस वाई क्यूब जेड स्क्वायर माइनस वाई क्यूब जेड स्क्वायर. इसको सॉल्व कर सकते हो. कैन यू सॉल्व इट? वी कैन ओपन अप. दिस इज फर्स्ट टर्म को यहाँ ले लीजिए. आई कैप डेल ओवर डेल एक्स ऑफ 3x स्क्वायर वाई माइनस वाई क्यूब जेड स्क्वायर प्लस जे कैप डेल ओवर डेल वाई ऑफ 3x square y minus y cube z square plus k cap and del over del z and this term again 3x square y minus y cube z square. ये डिफरेंशियल है सिर्फ. You differentiate this term with respect to x, you differentiate this term with respect to y, you differentiate this term with respect to z. जो आंसर आएगा उसमें x की वैल्यू 1, y की वैल्यू -2 एंड z की वैल्यू -1 फिर पुट कर दीजिए. आफ्टर 2 स्टेप्स यू विल गेट दिस आंसर. तो से फॉर एग्जांपल मैं पहली टर्म का डेरिवेटिव दे देता हूँ. जैसे दिस इज इक्वल टू आई now del over del x of this minus del over del x of this. तो विद रिस्पेक्ट टू x अगर आप इसको डिफरेंशिएट करते हो तो इसका क्या आ जाएगा आंसर. 3y तो कांस्टेंट है. x स्क्वायर क्या हो जाएगा 2x. तो 2x मींस 2 3 जा 6xy माइनस डेल ओवर डेल एक्स ऑफ वाई क्यूब जेड स्क्वायर. वाई इज कांस्टेंट, उसका विद रिस्पेक्ट टू एक्स इज 0. यहाँ पे भी कोई टर्म नहीं है एक्स की, अगेन इट इज इक्वल टू 0. सिमिलरली प्लस जे एंड डेल ओवर डेल वाई का निकाल लीजिए. यहाँ पे 3x स्क्वायर वाई है, वाई वाई के साथ वाई वाई 1 एंड हियर यू आर लेफ्ट विद फ्रॉम द फर्स्ट टर्म इज 3x स्क्वायर एंड डेल ओवर डेल वाई ऑफ सेकंड. सो दिस इज माइनस वाई वाई क्यूब, इसका क्या हो जाएगा 3y स्क्वायर जेड स्क्वायर. ये डेरिवेटिव आ जाएगा इसका सेकंड का. एंड थर्ड का सिमिलरली यू कैन डू. एंड थर्ड भी आपके पास क्या आ जाएगा, कर लीजिए. चलो इसको, दिस इज प्लस के इनटू डेल ओवर डेल जेड ऑफ 3x स्क्वायर वाई. x स्क्वायर वाई मींस व्हाट 0 बिकॉज z की कोई टर्म नहीं है. माइनस z स्क्वायर क्या हो गया 2z. तो दिस इज माइनस 2y क्यूब z y क्यूब z. ये आपके पास डेल ऑफ फाई. नाउ यू पुट x इक्वल टू ये आंसर आ गया आपके पास. You just put the value. You are given that phi is equal to this at this point. X की जगह आप 1 पुट कीजिए. इंस्टेड ऑफ राइटिंग y you write -2 and this is -1. तो x की जगह आपके पास 1 है और y की जगह क्या -2. तो यहाँ पे ये वैल्यूज पुट करते रहिए. x की जगह आप 1 पुट कर दीजिए. यहाँ पे y की जगह -2 that is -1 and final answer you can get. So you will get, after you substitute these values, then del of phi is equal to, this will give you -12y minus 9j, 12y, then is minus 9j and minus 16, probably it will be minus 16k. So this is the answer or required solution of this problem. So these are the topics which are very important, and this is for today's lecture, and I'll send you the notes of today's lecture also, and kindly do that, and we'll meet tomorrow. Thank you.